Hi everybody. I had a question asked about what you do once you solve a 3 by 3 and you find out you have infinitely many solutions, how you get it written in terms of z. So I thought I would make a quick video and share that with everybody because I thought it was something that probably a lot of you have questions about. So what I've got here is I have a 3 by 3 system that I have solved down to the point where the question was occurring. So I had taken my equation 3, multiplied it by -2, added it to the equation 1, and that eliminated my x's. So I got this resulting equation with only y's and z's. And then here I ran through that process again using -3 this time times this equation 3, added it to equation 2, eliminated my x's one more time, and another equation here with only y's and z's in it. So at that point, what we do is we take those two resulting equations, this resulting equation and this one, and we combine those one last time to eliminate either the y's or the z's. So my thought process here was I was going to eliminate the y's, and in order to do that, I needed to multiply this top one by -2. But in the process of doing that, I actually eliminated everything, getting 0 equals 0. So when all of your variables drop out and what you're left with here is true, 0 does equal 0, so it's a true statement, that's when you have infinitely many solutions. And this was the point where the question was occurring, which was, I know how to get to that step, then what? How do I write it in terms of z? So here is where we're going to pick up. What you want to do is you want to pick either one of these equations, because when this happens, what they're saying is these two equations are essentially the same. One is just multiplied by a number. So we want to take either one of these equations, solve it for y, make it say y equals, because that will let z be what we call the parameter. So I wrote a little note here that basically what you're doing at this time is you're doing that same back substitution process as when you get a regular number answer, except now we're having to do it with equations instead of numbers. So we have to go back and we have to do some back substituting at this point. So what I'm going to do is I'm going to take this, or I'll do it from up here. I'm going to take this equation just because it's got the smaller numbers. No reason other than that. And I'm going to solve this for y. So first thing I'd want to do is I would want to add my 21z over to the other side. So I'd get, what, positive 21z plus 14. And then I would need to go through and divide everything by -7. If I divide by -7, then I would get -3z minus 2. So that's what y is. What this tells me then, as I'm going to eventually find an ordered triple, is I don't know what the x's look like at all yet. But I know that the y's look like -3z minus 2, and z, the parameter, gets to stay itself. So this right here is what my ordered triple so far looks like, and I still need to go back through and find x. So in a quote normal one, if we had found a number for z and a number for y, what we would do is we would go all the way back up to our original equations and we would sub the z and the y value in and find x. We're going to do essentially the same thing here. So I'm going to choose this equation out of the three. I'm going to choose this bottom one. Because it's simpler, it's got the easiest numbers to deal with, and also because I'm trying to solve for x. This is the easiest one to solve for x since x only has a 1 coefficient. So I'm going to bring that down here. I don't know why I've got that going on. Okay. I'm trying to solve for x. I'm going to substitute in what y is, so it's 2 times y, but we just found that y is -3z minus 2. Z is itself. So I need to take this equation and I need to solve it for x. So first thing I might do is distribute, so I'd have x minus 6z minus 4 plus 4z equaling 0. So double check my work there, -6 and -4, that looks good. Now I might want to combine up my z's, so if I do the -6 and the plus 4, that would be -2z's and a minus 4 on this side. And finally, I'd want to move all of those over to the other side to solve for x. So I would add both of those over to the other side. So x would be equal to 2z and plus 4. Now that is what will go right up here as my x answer. So my x looks like 2z plus 4. And then this right here would be my final solution, all in terms of z. So what that means is I have infinitely many solutions. I get to pick a z value, and then there are very specific y and x's that would then match that. So it's not just any ordered triple in the world, like 1, 2, 3 doesn't necessarily work. But if I pick the z and pick the y and the x based on that z, then that would be one of my infinitely many solutions. So I hope this has helped you to know now how to get those written in terms of z, because that's certainly the hardest part. It's really just a bunch of back substitution of your variables here. All right.